Hello everybody. So in this video, I'm going to discuss project assignment number 4. So let me go ahead and share my screen and we'll get started. All right, so this is the template you're going to do your work on. On. Okay. So this is the template you're going to do your work on. This is my sample and then the rubric if you wish to look at it. So I'll go ahead and open my sample. All right, so in this assignment, we're basically going to use our quantitative variable from assignment 2, and we're going to do all sorts of numerical analysis on it. So you're going to use the quantitative variable from assignment 2, then you're going to answer the questions, use our guru or show work where it asks for it, and then save the document and upload it to Blackboard. So you will have 2 attempts for this assignment as always. If you meet all expectations the first attempt, you get 100%. Otherwise, you get a 50% till you make the revisions. And then you either get all expectations met, most expectations met, or meets less than 50% of the expectations. Hopefully, after you make all the changes, you should be getting 100%. And those changes are due within 7 days at the latest. The sooner, the better. And if you want to see what constitutes these grades, you can look at the rubric. So you're going to use the same variable you used in project 2 for your quantitative variable. So if I switch over to project 2 real quick. So in project 2, my quantitative variable was salary. So I'm going to use that same variable here. So the first thing we need here is we need all of this information here, which we can get in one swoop on our guru. So let me go ahead to our guru here. So to get all that information, you're going to go to Analytics, Analysis, and then Numerical Summaries. You're going to select the data set, and then select the variable, and then univariate, and then we need the mean, the median, and the mode. And then we also need the 5-number summary, which is the minimum, Q1, median, Q3, and maximum. We also need the range in the IQR. And then I also need the sample standard deviation since my data was a sample. If you're not sure if yours was a sample or population, check your project 1. Hit the eyeball. And then all I need to do then is put all of these numbers into my boxes. And once again, if you wish to save it, you can put a title here and save it. So now let's talk about finding outliers. So our lower bound is Q1 minus 1.5 times the IQR. So you can go ahead and plug in your Q1 and your IQR into that formula. Make sure you do the multiplication first or put it all in one swoop into our guru. I can show you in a minute how to do that. And then for the upper bound, it's Q3 plus 1.5 times the IQR. So my Q3 is 134,185. My IQR is 43,185. Put all that into the formula and we get this number here. So I'm going to go to our guru here and show you how you can put that in the calculator. So you can go to Applets, Desmos, Scientific, And then it's easiest here to just type it all in one swoop so that you don't mix up your order of operations and forget to do the multiplication first. So 91,000 minus 1.5 times 43,185. Does that get me the 26,222.5? That was my lower bound. And my upper bound, Q3 is 134,185 plus 1.5 times my IQR. So that gets me 198,962.5. So I'm looking for any numbers above the upper bound or below the lower bound. So the question becomes on our guru how we can find that. So we can go under data, functions, and then subset. Wait, no, it's not. Is it subset? Hold on. Yes, subset. And then select the data set. So I'll do the lower bounds first. Create a logical expression here. Hit this green plus sign. And I want to know if the salary is less than my lower bound. My lower bound being 26,222.5. And then hit done and hit the eyeball. And this will pull up all values below 26,222.5. There are none here. So let's now do the same thing again for the upper outliers. So functions and subset. Select the data set and the variable, or sorry, just the data set. And then logical expression, hit the plus sign, select the variable, and then I want to know if it's above the upper bound. So above 198,962.5. And then hit done and hit the eyeball. And I can see here, so we ignore everything except for the variable we care about. So my three outlier salaries that are above that 198,962.5 are 231,545, 204,000, and 205,500. So that is going to be our outliers for this data set. So let me go back to the document here. So you can see I listed those out here. If you get a ton of outliers, like if you get like, more than 20 outliers, then you can just list something like 25 outliers above the upper bound, for example. So like above 198,962.5. Just make sure that, if you have all those outliers, you probably would want to check with me to make sure that it's good before you submit it, to make sure it's like what I'm looking for the outliers. Make sure you don't have to list them all out. That would only be a situation if you have like 20 or more outliers, or more than 20. Okay. So let's now choose one value from the data set that is not the mean and calculate the z-score. Be sure to state the value and the z-score. So I chose 150,000. Just pick some reasonable value that makes sense. Remember, the z-score is the data value minus the mean divided by the standard deviation. So that's what I did here. I got 1.198. Now let me show you how you can put that into our guru. So in the scientific calculator, you can make a fraction here, and then you can do 150,000 minus the mean, which was 113,706.5, over the standard deviation of 30,289.04. And I got the 1.198. Now you could also like put the top in parentheses so that it does that subtraction first. Especially if you're doing it in like another like phone calculator or something. And then divide. Now on here it makes the fraction, but on a phone calculator it wouldn't. So you would need to make sure that you do put parentheses around the top on another calculator. Oops, I Go to 0. There we go. Okay, so that's the z-score part. We're going to come back to this. I want to talk about the skew first. Let's do the box plot and let's do the skew first, and then we'll come back to the Chebyshevs. So to make the box plot, you're going to go under plots, create plot, and box plot. Select the data set and the variable, so move the variable over, and then just check horizontal and hit the eyeball. And there we go. There is our box plot. And then you can right click and copy the image to copy it into the document, or you can take a screenshot. All right, so now let's talk about the skew. So I think it's easy to see skew from the histogram. So I'm going to go back to project 2 to look at the histogram. So I can see here looking at this histogram, I have more data on the left half than the right half. So that tells me it's skewed to the right. Remember, it's the opposite of what you would think. So I'll show you where I got that from here. So based on the box plot and the numerical summaries, it's symmetrical or skewed, and it's skewed to the left or the right. So I think it's easiest to see it from the histogram. You could also see on the box plot that I have everything's kind of shifted to the left here, so that makes it skewed right. So because we have more data on the left half than the right half, in both graphs it's skewed to the right. And now let's go back to the Chebyshevs here. So you're going to do either Chebyshevs or the empirical rule. Now, you're going to use the empirical rule if your data set was symmetrical, Chebyshevs if it is not symmetrical. So if it's not symmetrical, like mine is, which yours probably won't be, then you're going to use this diagram here. If it's symmetrical, you're going to use the empirical rule diagram from the empirical rule notes. Just as a reminder of what that is. In the section 2.6.4 notes, there is a diagram for the empirical rule right here that you can copy this diagram. The bottom here, the numbers you got to fill in are going to basically be the same. The only difference is the diagram. So I'm going to go back to mine now so I can talk about how we fill in the bottom there. So this is basically the same thing as the other one. The other diagram just used population mean and population standard deviation. And then this diagram uses sample. Well, actually it has it down here. This one has both the sample mean and sample standard deviation and population mean and standard deviation versions. But regardless, on any of the diagrams, the middle is the mean. So my mean was 113,706.5. And then this is the mean plus 1 standard deviation, mean plus 2 times standard deviation, mean plus 3 times standard deviation. And the mean minus the standard deviation, mean minus 2 times standard deviation, mean minus 3 times standard deviation. And remember, you're going to be doing this on the empirical rule 1 also if you have a symmetrical data set. So let me just show you how we can get these numbers here. So my standard deviation was 3289.04. So if I go to my calculator here and I do 113,706.5, which was my mean. Okay. And then we want to do plus 1 standard deviation. So just plus the 3289.04. So that's the first value to the right. So that's the 28 I'm sorry, the 143,995.54. And then for the second number, it's 2 times the standard deviation. So you can just do 2 times the standard deviation. So it's mean plus 2 times standard deviation, that gave me the third number. And then mean plus 3 times standard deviation, that gives me the number to the farthest to the right. So that's like the right side. And then for the left side, you're going to subtract the standard deviation. And then you're going to do minus 2 times standard deviation. And then minus 3 times standard deviation. And that's going to give you all of the numbers to put on the bottom. Now, if you have an issue putting them on the bottom like I did, you can list them out if you don't want to put them directly under the diagram. Um, that's fine. Just make sure they're in order. All right. So let me go back to the document here. So like I said, if you can't fit all the numbers on the bottom here very easily, then you can always list them out in a list to just make sure they're in order. And that's all you have to do for that. Just make sure you use the right diagram and calculate all the numbers. And then the final step, talk about what you did. So talk about what you see. What do you notice? How do they relate to each other, etc. Just talk about what you see, what trends you see, what do you see about the skew, etc. So based on my histogram box plot, I could see that my data set was skewed to the right because I had some high outliers that were skewing my data set to the right. So I had a cluster of values around the mean, and then I had a couple high outliers around like the 200,000 or higher range. And so from that kind of analysis, um, okay, from that analysis, I want to know basically why there's a couple professors that have higher salaries than everybody else. Is there some factor that's contributing to that, etc.? So just kind of talk about what you see. Talk about the outliers. So my outliers here kind of pushed my data set to the left because I had a couple high outliers that kind of just pushed everything else down to the left. Um, you could have a couple low outliers that maybe are pushing everything to the right side of the data set and skewing it to the left, or it could be symmetrical. Just talk about what you see, the outliers you have, why that might exist, etc. And that's pretty much all you need to do for that. So you can kind of use mine as like a model to kind of talk to see what I'm looking for, what I'm looking for you to talk about. All right, and that is it for project assignment number 4. If you have any questions, please feel free to reach out.